All right. Well, welcome to today's NCARB Live. Let's get started. Thank you to everyone for joining us today. My name is Andy McIntyre. I'm the Vice President of Marketing and Communications here at NCARB, and I'm going to be your moderator for today's webinar on designing for deconstructability and reuse. So I'm joined today by two expert panelists in Felix Heisel and Dena Prastos. They're going to share their knowledge and insights around our topic. Again, I'll say it again, designing for deconstructability and reuse. So before we get started, I'd like the panelists to give a brief introduction to themselves. And Dena, we'll start with you.
All right, great. Thank you for having me. It's wonderful to be here. I'm thrilled to be part of the conversation today, especially alongside Felix, whose work continues to challenge and inspire our field to think more regeneratively. I am a practicing architect. I have a firm in New York. I focus on resiliency and waterfront infrastructure, so not typical buildings, not typical design. But I am a practicing architect, and I've spent much of my time navigating the tension between what we design and what we leave behind. So it's becoming increasingly clear that our profession is at a turning point, and this conversation is apropos. So I'm looking forward to having the conversation. Turn it over to Felix.
Hello, everyone. Thanks for inviting me today. Name is Felix Heisel. I'm an assistant professor at Cornell University and director of the Circular Construction Lab. I'm a trained architect. I have an office in Germany, and I'm licensed in Germany. But the focus of today's conversation will be the work that we do in research and academia at the Circular Construction Lab. I'll turn it back to you, Andy.
I have some housekeeping things to do. I'm going to do without the slide, and then I'm going to pass to you, Felix, for your presentation. Okay. But just very quickly, and I will share this towards maybe when we come back after your presentation, we'll share the learning objectives for anyone who's looking to get health, safety, and welfare credit for being part of our webinar today. So I do want to note that this webinar is being offered for continuing education credit. It is worth one health, safety, and welfare learning unit. And at the end of our webinar today, there will be a QR code so that you can enter, and that will link to a site where you can enter your information, AIA number, etc., to receive that credit. And if you do miss the QR code at the end, don't worry. We will also include the link in a follow-up email. Okay. During this hour, you'll learn about circular construction principles and how they can be used to advance sustainability in architecture. And we'll also discuss how this may affect the future of architectural practice and regulation. So remember, you can submit questions throughout the presentation using the Q&A tool throughout the webinar. And if you have to step out at any point, a recording of this webinar will be available on NCARB's YouTube channel. Okay, so here are my colleague has stepped in to help me out and is sharing the learning objectives as we speak. So we should be good on that. All right, okay. With that, I think we're going to give you the floor, Felix, and invite you to give us an introduction to deconstructability and reuse.
Great, thank you. I was asked to speak a bit louder, so let me know if you can hear me well or not. And I hope you can see the screen. Thanks for the introduction. As you mentioned, we're talking about design for deconstruction or deconstructability and reuse today. And it's sort of started or founded in an understanding of our built environment's impact. If you take buildings together, building an infrastructure from the beginning to the end of their life, then we're estimating that about 50% of the resources that we're taking out of the Earth's crust can be attributed to that industry. We all know by now that 41% of carbon dioxide emissions come from the built environment. But also 40% of solid waste generation can be attributed to the built environment. And so that's, of course, a massive impact that we all sort of contribute to. And if we look at at one of these, the carbon emissions in a bit more detail, we all know this exponential growth chart. What is interesting, and these are numbers from Architecture 2030, is that if we want to achieve or meet the Paris goal climate agreements to limit emissions to the pre-industrial time or reduce them, then we need to reduce emissions by 65% in the next couple of years. This chart talks about pre-2030, and we all know how long cycles are in the built environment, right? So this is basically we need to reduce by tomorrow, considering the time that it takes to build a building or go from design all the way to the opening of a building. And so the Circular Construction Lab really addresses this from two angles. One being, what do we do with all the materials that are bound in today's buildings in the existing environment? And what kind of techniques and technologies or tools do we need to reactivate these materials for the market? And then the second question being, how do we design differently moving forward so that the buildings that we're building now don't run into similar questions at the end of their life in 2050, hopefully 200 years down the road. The team is a group of students here at Cornell University, ranging from the bachelor to the master to the PhD program, but also ranging across different disciplines, from mycology to biology to architecture to engineering, because it's a systemic question that we're trying to answer. And so this cross-disciplinary, I think, is a key in how we answer these questions. And what we're aiming towards is this sort of circular ecosystem. What you see on the screen right now are different ways to close the loop, to design both the raw material sourcing and waste out of the system. But what I want to highlight is sort of the importance of that reuse cycle as the most direct, the most local of the circular economy strategies that we have to choose from. And with that, the most impactful. And we'll go into more detail on that question in the next couple of minutes. The problem is that the realities look more like this. This is a picture from a recent demolition site here in Ithaca, New York. The contractor is very proud of this image. It shows how the steel is being collected, how all the concrete is being collected. The concrete is all ground down, recycled into aggregate, or in this case, clean fill. And all the steel is recycled and sent to overseas. But it also manifests sort of the problem of maybe the recycling industry, right? That we're celebrating the fact that a former structural material is used as clean fill on a landfill, and that steel is shipped kilometers or miles across the ocean to be recycled, and the emissions from that ship probably offset the recycling impacts of that steel. And so the recycling industry is a global industry that needs these global impacts, and with it come externalities that I think we are not completely understanding in their totalities. Another example is this aerial picture. This is a development in Ithaca, again, a case study where we were able to convince the developer to deconstruct one of 11 houses that were taken down for a new development. And so what we're comparing here is really demolition and deconstruction of similar housing typologies right next to each other in an academic sort of case-by-case scenario. And so our proposal was panelized deconstruction. What this means is we're essentially cutting the house into the largest possible pieces that still fit on a flatbed truck to then bring those off-site and reactivate the materials by taking these panels apart right at an off-site location. And what this does is it essentially gets us to be cost and time competitive with demolition in this specific case study. So after 4.5 days, this 4,500 square foot house with 13 bedrooms, a student housing project, looked like this, all panelized at this local reuse center here in Ithaca. And the comparison in the end resulted in numbers that showed that the resale value of the materials that we salvaged offset the additional labor that was needed for the deconstruction. And so the question then was, what do we learn from this? What do we want to, why do we want to engage in deconstruction? And what can we add to this conversation? And so one big question was, what is even in these buildings? What kind of tools do we need to pre-demolition or pre-deconstruction make smarter decisions? And so we're working on a tool, this is called Scanner, that estimates material quantities with a very low-res scan, so using your cell phone to get a really low-res point cloud, and then connect that with open data and available archetypes to make detailed estimates about material quantities and potential reuse scenarios for these materials. We did, as I mentioned earlier, a very detailed analysis of the benefits between, or the impacts of demolition and deconstruction. Here you see this offset of the revenue that then can be attributed to the labor cost. But it also shows, of course, the benefits from an environmental perspective in the embodied carbon that was saved, for example, through this project. And that's sort of the point that we maybe want to talk about most. It, of course, is a workforce development opportunity, right? So if you're, instead of a demolition project tends to have about 2 people on site, right? Someone that drives the excavator and someone that holds the hose. In a deconstruction project, you have about 6 to 8 people on site. That's where the additional labor cost comes from, but that's what we want to show as an opportunity for workforce development, for green workforce, for local salaries and wages, and for the development of that workforce within a larger context. And so one recent work that we did was extrapolating these benefits to a state level. In this case, these are numbers for New York State. We published a white paper estimating the potential of a shift in this. We're assuming about 15 to 20,000 residential demolitions in the state. If we're shifting either 50 or 75% of those demolitions to deconstructions, that has a $3 billion economic impact that saves about 90% of these materials that still have value in the end and creates 13,000 jobs. So there's not just an environmental argument for deconstruction, but there's an economic argument for deconstruction, which was important for us to make. And this white paper then moved on to say, okay, what kind of framework do we need to make this successful? And so we proposed 19 policy recommendations along the value chain of materials in deconstruction projects. And they're grouped in these 5 categories. How do we build the workforce? How do we build the market? How do we build the infrastructure that sustains an economy like this? And what kind of examples or opportunities does the state have with its large portfolio to lead by example? And what kind of policies do we need to sustain these projects or this economy long term? And it's amazing to see how this conversation is sort of gaining speed. I brought you something here that was just put on the Senate introduced into the Senate on May 16, so just Friday, which is a bill that is run through Senator Kavanaugh and Assembly Member Kellis, that proposes sort of the introduction of a materials of a deconstruction ordinance. This essentially shows a template deconstruction ordinance and incentivizes the application of that through support in running the ordinance, in training the workforce to do the work, and in infrastructure that is necessary to handle the materials. And so if you're interested in this is now live. You have the Senate bill here, S8168. And I'm sure if you're in New York, your local senator would love to hear from you on this. I'm shifting gears a little bit for the second half of this talk, because there's one thing about how do we deconstruct buildings, how do we generate a material supply? But the other question is, where's the demand? How do we match demand and supply? And so how do we design differently? This is an example from my office that we built in Switzerland. It's called the Urban Mining and Recycling Unit. And I just wanted to point out that there are full-scale successful examples, and not just from me, but there's a lot of really good case studies out there right now that prove sort of the versatility and the technical feasibility of circular economy thinking and circular economy design. So this specific building is designed so that 100% of the materials that went into it can afterwards go back into their specific material cycles as pure materials for reuse, recycling down the road. This is an example where we used only secondary materials. So there's no virgin materials whatsoever in this project. The steel, for example, is directly reused steel from a former coal-fired power plant. And that, of course, asks questions about how do we design with a non-standardized stock, or how do we get those through certification processes? And that's, I think, where these demonstrator projects become so important to pave the way for a more industrial or industry-wide application. I want to talk a little bit more about a local example that we did in the lab. This is called Circulating Matters. And it's a small structure on the Cornell Art Squad that was built from some of the materials that we gained in that deconstruction project that I showed you earlier. And the interesting thing is, although it's a really small structure, it was large enough to require a full building permit. And with it, sort of a kind of demonstrator of the steps that you need to go from salvaged lumber to structural reuse, which in most states currently is not allowed. And so we learned about the processing of the materials, about the qualities of 100-year-old patterns, or the relationship between sort of a fresh, new treatment of timber with these old patterns. So those are kind of the aesthetic and the architectural means, but we also learned about material passporting. How do I make sure that I know where a material comes from, where it is now and where it is going to be next, and how I connect so the digital and the physical, or how do I detail with a non-standardized stock where you have a tolerance difference of about 1/2 inch between different lumber pieces, and what kind of changes does that make or require in the way we detail our construction. But most importantly, towards the sort of structural reuse was the question, how do we design and engineer when we don't have certainty in design values, in engineering design values? And so we did an analysis of how do we determine, for example, the species, because right now the path of the engineering design path is by figuring out what is the species, going into your textbook, looking up the numbers, and then using those as your calculation inputs, right? But if you don't know the species, how do you do this now? We send out samples to 3 different experts and got 3 different results. So we were kind of discouraged from that as sort of the standard. Other alternatives are, of course, static bending tests, but the sample sizes usually omit that. And so one option that we see valuable is to go by density or the specific gravity, because that's something you can do easily, small samples, you can do it on site. And it turned out that the density actually is a really good determination for structural strength in this case. But that's something that we keep working on. Maybe more interesting is the question, how do we maybe go down the regrading path? We're currently developing technology that uses AI and visual grading algorithms to automatically specify the grade of salvaged lumber that is in development, but I see a really big potential in sort of technology applications that help us create a cheaper path to reapplication. Because of course a visual grader is available, but all of these steps require time and cost and are usually barriers to scaling a process like this. But again, there is also ongoing legislative development in these areas. This is another bill that is currently in New York State, discussed in the Assembly, that would automatically assign a stud grade 2 to salvage timber. This is not a new invention. This is something that was that has precedent in both Washington State and Oregon State, which have similar codes and legislation already on the books. And that's an amazing step, right? Because you have suddenly an auto-assigned structural grade to lumber that comes from deconstruction projects, and at least allow you to do, timber framing. But that's in our case like 90% of projects, right? At least in residential market in New York. And then to kind of close out, we're also developing design tools, because we noticed that usually the conversation about circularity comes too late. This might be an outdated statement, because so much has happened in the last 2 years in our industry. But when we started developing the tool, usually the question of circularity was something that was discussed at the end of construction or at the end of the design process, towards documentation for the future. So how do we now make a material passport for this after it's been designed, right? We learned this the hard way in our own project, the Urban Mining and Recycling Unit that I showed earlier, where we designed the whole thing and then afterwards created a material passport and generated all these numbers for it. And then we thought, well, this would have been really great to know early on, and integrate and use it as a design and decision-making tool. And so Rhino Circular is a free software for anyone that's using Rhino and Grasshopper that can do that for you, that can sort of embed this information into the platform in the canvas, and just give immediate feedback to design decisions. And I just wanted to make people aware of that option. We also write a lot about circularity. So these are some resources if anyone is interested to learn more. And with that, I'll pass it back to Andy to have a conversation about some of these components.
Well, thank you, Felix. And on behalf of us and everyone listening, thank you for that presentation. There's some really sort of interesting and important threads in that space. But I'll start. I'm going to let you have a minute or two to reset and start with a question to Dena. And Dena Dena is the chair of NCARB's Futures Collaborative. So someone that I know personally. Dena, with your Futures Group hat on, could you tell us a little bit about this topic and why it's important to Futures and why Futures were interested in exploring it?
Absolutely. So two-part question, and I'll start with what Futures Collaborative is and why we were interested in this topic, and then how and where we see it fitting in the future of licensure and regulation. So in NCARB's Futures Collaborative, we're charged with scanning the horizon for forces that are reshaping the profession and the practice of architecture. And few topics are more urgent or consequential than the shift towards circularity in the built environment. So when we design for deconstructibility and reuse, that directly intersects with our mission as architects, because it's reframing the architect's role from simply creating structures to actively managing their full life cycle. So from assembly to disassembly, from idea to ideally regeneration, that challenges some of the long-held assumptions in our profession and invites us to rethink what competencies, what responsibility, and what stewardship really means in the 21st century practice. So we were particularly drawn to this topic because it's not just theoretical. It has real implications for construction documents, for material specifications, for risk management, for ethics, for sustainability. And those are all core attributes of what we expect licensed architects to be tracking also as trends in the industry now and into the future. And so looking ahead, where we see reuse and deconstruction in the future of regulation, the future of licensure, different thoughts, and we've debriefed a lot on this topic because we see the growing need to integrate circular principles into the regulatory framework, and perhaps not as a standalone requirement, but really embedded and integral to the existing competencies. So Felix shared a couple examples, and certainly could mean updating model codes, updating Senate bills, updating licensure content to include the knowledge of reversible assemblies, in essence, as well as materials passports and adaptive reuse strategies. It could also mean encouraging jurisdictions to recognize project experience that involves life cycle analysis or disassembly planning. So ideally, we're preparing architects to take responsibility for the full life and the afterlife of the buildings and the built environment that we are responsible for creating.
Great. And I know, Felix, when we first spoke to you back towards the end of 2024, I don't know that the Senate Bill S8168 was sort of on the radar. So that's obviously new news and presumably has really real significance for people in this space. I think one of the points that you mentioned that's worth highlighting is that the cost and time competitive aspect with demolition. And the fact that I think everybody can see why this is an important topic from a sort of ethical or a big picture resource stewardship perspective. But how does it pay for itself, and how is it efficient in that context? And just in terms of sort of when people think of the built environment, Felix, where's the biggest opportunities do you see? Are there particular building types or scenarios where this should really be at the forefront of people's mind, not necessarily just because it's a good thing to do, but actually because it pays its way?
That's more than a two-part question. It's like a 10-part question. I'll try and wrap my head around it. So when it comes to sort of the first part of that question about how does it pay for itself, or what other parts of the conversation are there, I think it was really important for us to show that it is cost and time competitive with demolition, because then we can start talking about the things we really want to talk about, right? So that's kind of the lowest bar to get into the door. And then we can talk about the fact that deconstruction, for example, is much healthier, right? It reduces air pollution in the neighborhood and on the construction site. It's better for the worker in that case, but it's also better for the neighbor. It has a proven much higher record in abatement, right? So because when you carefully unbuild something, you find those pieces that the abatement usually doesn't find. Like, I mean, traditionally, right behind the switchboard, right, there's another piece that is asbestos. That's hot. That was forgotten in the abatement process. And so deconstruction is going to find these things and take them out of circulation. much better than the normal demolition process would do. And it creates a local workforce, pays better wages, more wages, and it's a way to keep historic significance in the community, right? Because these materials are not going to landfill, they're going into the next project. And if there's, for example, significant elements, they will be reused in hopefully a meaningful way. So it paves the way also for kind of historic and social relevance of and continuity in the projects. Now the question about the low-hanging fruit, I think, or the starting point and the significance of this, I think part of it is you can always do soft stripping, right? That's sort of the low-hanging fruit. You can, in any project, you can make sure that you go in, you take out the floors, the finishes, the fixtures. That's really the low-hanging fruit. But interestingly, if you look at it from an economic perspective, for example, hardwood flooring is one of the most valuable things to take out of a building because there's a market for it. You can just actually put that into the next building without doing anything about it and then plane it down in its new configuration and have a beautiful floor that is worth a lot of money, and you get it for like half price. So there is a market for some of these materials for immediate application without changing any code. So that's sort of the low-hanging fruit. The other sort of easy next step is probably salvage lumber, because there's a lot of conversation about this topic right now. I mentioned some of the code changes that are about to happen in terms of or legislative changes that are about to happen. What I haven't talked about is code changes. The ICC, for example, is right now in the process of debating an update for the 2026 International Construction Code that would integrate salvaged lumber through a on-site, very low-tech testing system where you basically do a 3-point bending test while you have it up for denailing. You just hang a couple weights on it. If it survives double the load of what it's supposed to do, you're allowed to use it, right? So there's ways that are many different paths towards application of these materials that are being prepared right now, and it's really exciting to see. It gets more difficult with other material streams and with other typologies, but what we should, I think, start with is residential timber constructions, and that is something that in many cities across the nation actually is already happening. We have, I think, 10 deconstruction ordinances, for example, across the US, the largest in San Antonio, the earliest one in Portland, that all require the deconstruction of residential buildings that were built before 1940, for example, or 1920, depending on their detailing. But that's because there's value in these materials.
And I assume that there's a relationship between between having a deconstruction ordinance, the amount of therefore recycled material available in the system, and then the ability to then design for the reuse of those materials in buildings. And I just want to, I know that obviously you're with the Circular Construction Lab, and that circularity is fundamental to that. Is there a chicken and egg relationship here that people need to be mindful of?
Yes. I mean, as with any value chain, you need to meet demand and supply. Like if you're overproducing on one side and you're taking lots of buildings down, and the material gets stored in warehouses, and those warehouses fill up and no one wants the material, you're driving up the price, or you're driving up the cost, right? Because you need to rent these warehouses. Every time you touch the material, you add to its cost, right? And so that's a problem. The flip side is also a problem. If you have lots of architects asking for materials, but you can't meet those demands, then the architects will stop designing for reused materials, right? And so it's a really important relationship. And again, I guess legislation and code can help mediate this to some extent. We've seen in Portland as the earliest ordinance, and so there's a little bit more data available now, that through the generation or through the adoption of the ordinance, the city went from, I think, 2 to 17 certified deconstruction companies. They create a kind of sort of reliable, consistent amount of material, which now architectural offices can use or design for. I think there is a lot of room for improvement on that side, especially in the digital space, by creating marketplaces that, for example, make materials available pre-deconstruction or pre-demolition through surveys or audits. And so by that, the dream world would be a kind of on-demand system where you already designed the house before you take down the donor, right? And so then the materials can go directly from the deconstruction site to the construction site. That would be the most cost-effective method, but it requires a much more detailed data infrastructure in the background.
Yeah. So you've talked about a number of factors at play with the code and obviously legislation within jurisdictions. When we think about the regulatory framework and we think about what's expected of the next generation of architects, I'll start with you, Felix, and ask the question from an academic's perspective, because obviously you're teaching at Cornell. How are you integrating this into curricula, and what are students, how are they connecting with this topic? And what are they gaining from that connection?
Yeah, it's an important part of how we engage students, especially that second part. So the research is actually more focused on the supply side. And then so the technologies of how we take buildings apart or how we treat materials. The teaching is heavily focused on, so what do we do with those materials and how do we design differently moving forward that future buildings don't have these same problems? I think that's something we haven't really talked about much yet, because I think the ideal scenario for a future building is that we don't have to mine it, like by taking it apart and cutting it and sort of having byproducts and wasting it and getting asbestos out of it. Unfortunately, that isn't happening anymore. But I think even modern construction has a lot of toxicants in it that we'll have to think about if we want to circulate those or not in the future, right? So I think a new house today, if it's designed for disassembly, acts more like a warehouse or an asset management for reuse, where you have reversible connections that you can take apart and reconfigure in means that do not resemble mining processes, right? That kind of dusty cloud thing anymore, but more like warehousing and asset management. And so that's something that we do and talk about a lot in teaching, and something that the students are extremely excited about. And so I think the next generation that's coming out of academia right now, because this isn't something that is restricted to Cornell. Many of our colleagues and probably many in the room today are teaching similar things in the academic realm. And so I think there's an exciting new generation of architects coming to the market and towards licensure that will have these ideas partially ingrained into how they work and how they operate.
Great. And just for everyone watching, if you do have questions for Felix or Dena, please put it in the Q&A. We'll get to that very shortly. So Dena, I'm going to come to you on that, sort of following up on Felix's comment. Thoughts on the sort of the regulatory framework as we know it today. How could this topic plug in, and what might the future of that structure look like, given this growing theme and its importance?
Sure. So I certainly agree with what Felix said, and I think that's one component of it. We can kind of break it down in the NCARB framework of education, experience, examination, and even in practice and continuing education. But kind of before diving into each of those or the remainder of those, I think it's kind of under the headline of a cultural and professional shift, and it's reframing waste as an ethical issue, not just a technical one. And so that's something very much as a profession we need to be on the same page about moving forward, because we are in business, and if we're not all upholding that same standard, the business model won't support some thinking that way and others not. And so it's a challenging dynamic within the profession to push forward on that boundary and to assert that, waste is an ethical issue, and we as architects licensed to protect health, safety, and welfare of the public take that seriously, and that waste is not something that we should be consciously perpetuating in our society. And so that comes into materials documentations and registries and how we practice. And so certainly on a experience level, I loved the slide about the project on campus at Cornell, and that in my mind, it's no project is too small to go through this, because you're right, you go through all the checks and balances of a larger scale project, but you become kind of intimately more familiar at a small scale in a rapid time frame. And that's a really valuable exercise for whether practitioners or students or aspiring practitioners to go through. So I think it is a conversation of elevating kind of this circular thinking principle within the licensure model, because it's certainly a futures issue, but it's becoming very much a now issue as well.
And before we get to the sort of Q&A from our audience, one last question from me, which really talks to the sort of the impediments that the system currently faces for its sort of more widespread adoption and growth. So what do you see, Felix, as sort of the big limitations? And if you had a magic wand and could sort of change one or two elements of the current sort of system, what would those two things you'd change be?
Yeah, good question. I think on the economic side, that what limits us right now is that we tend to think from design till day one of a building's existence, and then we hand over and it's someone else's problem. That's sort of a societal, industry-wide issue. But if we were to take whole life cycle emissions and whole life cycle costing seriously, right, then the conversation about the value of materials at their end of use becomes a very different conversation, right? Because we can calculate those into the construction costs. And so certainly circular design wouldn't be more expensive if we think about it over the whole life cycle of the building. If we only think about it as an upfront cost, then yes, we'll have to add a couple percent to the construction, and that's sort of limiting maybe the large scale implementation of this right now. And so I think this has a lot to do with mentality and sort of the setting of how we act as an industry, like Dena just pointed out. I think it would be great to start there, because everything else sort of falls into place afterwards.
Oh, I think you're on mute, Andy.
I was. It was the same question to you, Dena.
So I think much of it is the mentality of life cycle design thinking, material recovery planning, adaptive reuse detailing, but something Felix touched on, I think it's beyond just the direct benefits of the life cycle cost for the given piece of the built environment. It's also the intangibles and the indirect of what is it doing for the community. Oftentimes large scale developers and large scale infrastructure projects have reporting quota around how many jobs are created. And when we look at our economy, the more that we can localize resources and labor, the stronger our communities become. And so there are a lot of intangibles that are indirectly related to this principle of this ethical consideration of what is waste and how can architects help extend the life cycle and reuse and adaptively put materials to work in a different way and adapt our workforce to also be agile in that way to be localized and to benefit our immediate local economy and communities.
All right, we're going to switch gear. We're going to take some questions from our audience. People have been throwing questions in the Q&A. And I'm going to start with a question for Felix, and feel free to sort of be tight through the answers because I think we've got a good amount of questions. So we'll see how many we can get through. Felix, opening question for you. So you mentioned panelized deconstruction. What other types of deconstruction are there?
I mean, the most traditional is sort of stick by stick unbuilding. That's sort of the traditional deconstruction. And you can imagine that as the reverse process of construction. So you start at the roof and you work your way down. And the product that leaves the construction site is sort of the dimensional lumber, or like it's the unit, right? Because you're processing the material on site. And that's the big difference to panelized deconstruction, where you're shipping segments offsite and do that post-processing somewhere else.
Okay. Next question. Do either of you have recommendations to make historic adaptive reuse projects more sustainable? There's a bit of a caveat here. Obviously, adaptive reuse of buildings is a great way to preserve existing buildings and their embodied energy, but historical buildings typically require more energy usage to condition the spaces. So, thoughts on that?
I can go ahead and start on. I work a lot on infrastructure and not typically on buildings. And one of the things that I find, even when we're working on a project that's maybe on the National Historic Register, is oftentimes outside the building footprint, there are a lot of opportunities to make more resilient the property. And the question was around sustainability. And I'll caveat that, sustainability, we're looking at our impact, our mankind's impact to the environment, and resiliency, we're looking at the flip side of that, of the environment's impact to the man-made. And so if we can consider both of those and consider making the surrounds and the site and the infrastructure more resilient, thereby enabling the structure, the building, whatever the historic building is, to be more sustainable, because we're not building something that might be susceptible and require renovation sooner than whatever the design life or the design period was intended to be.
I like that answer, and it triggers one point that I should have probably made during the presentation. I think the way we understand deconstruction is sort of the last resort compared to demolition. Any reuse comes first, right? So historic preservation first, then reuse, then adaptive reuse. And if we ever have to leave sort of the site or clear a site, then deconstruction is the alternative to demolition. So that just as a kind of important point to make. I think the answer that I would give to that question is I think the more biologic your materials are that you put in, the more sustainable. Like, yes, you will need to add a new layer of insulation materials. You will need maybe new substructures. And if you can source those from regenerative sources instead of, I don't know, adding a layer of spray foam insulation on the inside that then glues all of this together for eternity and creates a big composite waste product out of your adaptive structure, I think then you're on the route to something that is sustainable. And I think whole life carbon neutrality is something to take serious. Like, it's not just about bringing down operational emissions, but looking at it from both aspects, the embodied and the operational. And sometimes these compromises actually allow us to do something a little bit less performative, but in the overall performing better over a serious amount of time.
When we think about the skill set of today's architect or today's student, and we think about application in the space of really thinking about deconstructability, both in terms of using resources that have been recycled and also designing with deconstructability in mind. What's the skill set gap? Is there a skill set gap today? And if so, what needs to evolve or advance in order for the profession to really lead that and be good stewards?
There's definitely a skill set gap, something that we're trying to address in academia, and I think that's probably the key solution, to add that all into the education. And it has to do with, on the one hand side, I don't think you need to know how to take a building apart. It helps. But I think you need to know how to design with a non-standardized stock, which is a very different way of designing a building. If you start with a set of given materials, your structure is going to look different than if you start from an idea and then go to the catalog and select materials that fit that idea, right? But I think the only way to really design sustainable is if you're coming from your local availability and integrate that into a design. And in the end, that's at least my conviction. In the end, your design is going to be better because you start from the local resource. But that is a shift that I think we as an industry are performing right now, but it is sometimes painful.
Yeah, and I'll add on. I mean, I believe there are emerging practice competencies around life cycle thinking, um, but there are still core technical and design skill sets that are needed, and maybe they're more nuanced. Maybe it's building systems knowledge, so understanding structural, mechanical enclosure systems, but with an eye towards disassembly and reconfiguration. And maybe it's specification writing, but with a deeper fluency in material provenance, reuse grading, and health impacts. And there are certain things that we can now go a little bit deeper, understanding the implications of not. And so I think there are plenty of areas that we're already fluent in terms of competencies, but we can go another level and another layer deeper.
How do you sell the potential sort of return on investment from both from an environmental and economic perspective for this thing? And I assume when we say sell, so that's the question, but I'm assuming it's like from a client perspective, if we're thinking about sort of recycling material, or designing for, like, when we say, you mentioned, Felix, that one part of this research is thinking about the connectivity of parts and having things that are more easily easy to disassemble towards the end of life. How would the profession go about sort of promoting that as part of sort of making it become norm, shall we say?
Yeah, for me, it's always kind of I'm sometimes perplexed by the fact that we understand buildings as this sort of generational wealth building tool, right? So we design this thing and we pass it down generations. And if we're honest with ourselves, what we're building right now, we're passing down like a toxic landfill that costs money at the end to take care of. And so if we switch back to a system where we have disassemblable pieces that retain their value and that are free of toxins, and that in those pieces that we don't need can be composted, right? In an ideal scenario, I think that is a narrative that comes much closer to generational wealth building and the kind of idealism that stands behind what we can do, right? In a generational contract. That's one way to tell that story. There are many others. I'll let Dena add one.
Sure. So I would say currently adaptability equals longevity. And so a building designed for reconfiguration stays useful and valuable longer. And certainly there are other, market differentiations and limiting risk on disassembly and reduced end of life costs and other things. But I think the headliner is really adaptability equals longevity.
Okay. And I think this is going to be our last question, but it's quite a lengthy one. So I'm going to pace my recital of it. So pay attention. Okay. Can you speak to the challenge of integrating this kind of approach due to the traditional segmented construction industry? So we go from designers to contractors to manufacturers to suppliers. What should the future thinking be in integrating not just the project, but also the profession and rethinking the framework of buildings and buildings, building and building? So I paraphrase that question into, there are multiple component pieces with regard to the realization of a building project. And how does that all play with this in this sort of the space, which is obviously opportunity, but challenging as well?
Yeah, it's a really good question. I have an example from when we designed the urban mining and recycling unit, where we made it a mandatory requirement for every planner, so every subfield, to be present at a monthly meeting during the early design phases. This is something that's not possible in every scenario, and we're aware of this. But the benefit that it brought to the project was incredible. And so I guess my point being, if we actually increase sort of knowledge share and get out of our silos much more, as difficult as it is sometimes, we come to better solutions. In this example, at some point we were trying to figure out how can we design a sprinkler system or piping that is sort of following circular guidelines and what materials are out there. And we as architects, we're not so deep in the material that we would actually have the solutions. And the fact that the sprinkler planner was right there and said, oh, I know how to do that. We've done that 20 years ago. We've switched to a different system now, but we have that knowledge. That was an easy solution suddenly, right? But it only happened because we had everyone at the same table. And I think it's similar with deconstruction. I think we need that deconstruction expertise at the table as early as possible as well.
And your thoughts, Dena?
So I'd say it's perhaps overly ambitious to think that we'll have an answer and that'll change the industry. It's the truth is we won't transform the system all at once, and I think the path to success here is prototyping a new practice model inside the industry. And so starting with one project, maybe it's a small project with one team, with one city, and one client who sees the opportunity and the value, and then using that momentum to begin building new workflows, new tools, new standards that others can adopt and adapt. And yeah, the challenges are multifold and complex, but it's beginning to speak the language of what the value is here.
All righty.
At the time, Annie, sorry, just because you brought it up, there's just a shout out. There is one of these projects right now happening in New York City. The Spark project is sort of a demonstrator. We had a conversation on Friday at a panel about how do you draw a deconstruction plan and what is the specifications of a deconstruction plan? No one knows, right? But they're going through this process right now. And I think you're right. That will be extremely valuable for the industry to just have someone else make the mistakes or solve the issue. But I think we're all working together towards a new practice model.
Okay. Well, we've sort of reached our last few minutes for today's webinar. Before we wrap up, I would like to invite each of you, the two of you, to share a final takeaway or sort of piece of advice for our viewers. Anyone ready to leap into that?
I mentioned it before, but I kind of closed saying it, but there's no project too small to start. And it's a philosophy to embody that, there's waste and there is something better than waste, and we have the power within our industry and within our practice to find ways to adaptively reuse and specify for deconstructability. That is a pretty exciting seat to have at the table.
Yeah, and to just build on that, I think a lot of it has to do with awareness. Sometimes we're so stuck in the way we've done things over the last 20 years, and we'll just continue that. And so there's a lot of new knowledge being created every day, and keeping up with that, I think, helps us sort of solve these things differently. And so, yeah, let's all stay alert and be part of the movement together.
Yeah, and I will just say that when we first spoke to Felix and he shared his work with us, and it's rich, and it talks from an individual house sort of deconstruction through to the impact of statute and rules within a state. So there's various different scopes, but I think it's interesting that you're in an academic setting, Felix, and it's a study that you've done to determine whether or not that's a sort of economically viable act. And it'd be great to have some more firms out there who are really in the commercial space saying, "Oh no, we're going to do deconstruction on this project." Do it, and then come and tell us about it on a future NCARB Live, because we'd love to see that being sort of enacted by other protagonists. Okay, Dena and Felix, thank you both for sharing your expertise with us today. To make sure that everyone can continue can get continuing education credit, I'm going to now share my screen so you can get access to the QR code. So please scan this. That will take you to a site where you can register your AIA number and your name and etc. And if you have any reason can't have access to that, it will be shared in a follow-up email after the webinar concludes. Okay, I'll just take a moment for you to scan that code. All right. Okay. Yeah, after submitting your information, you will receive an email certifying your participation today. So please allow 10 business days to receive the confirmation email. For AIA members, credit will be automatically reported to AIA. Please allow please allow 10 business days as well for the credit to appear in your AIA account. All right. I think that brings us to the end of our webinar today. Thank you to our panelists for sharing your expertise. Thank you to our viewers for attending. If you couldn't see the entire webinar, you'll be able to watch a recording later on NCARB's YouTube channel. We're glad you were able to join us today and have a great rest of your Wednesday. Felix, thank you. Dena, thank you. Hopefully we'll see you at some point in the future.